Alrighty, it's time to do the Rigidbody stuff. So, first of all, we need to choose a character for our testing. I chose this little guy, but you can go to Mixamo, you can choose any character. The reason we don't want to use Mixamo is because these are all human-rigged characters, and that's important for the next step. These you can also choose animations in, so I searched up dance, and I just chose a dance for them, so that way they can do their dance. You can have them do all kinds of silly things. Because why not? There's a lot of cool things that you can do here, just because you can. So once you have it, you can download as a Unity FBX with skin, and the FPS is 30, which is fine, and the keyframe reduction we don't need. Download it, and then go into Unity, import it into Unity. Once you have it in here, you need to go to your materials, and you need to extract textures and materials. Then it'll create this, and you need to fill it out. So albedo to albedo, metallic to metallic, normal to normal, height to height. And once more, in the previous video, there is a download for this stuff. I've already made it of this guy, if you want to use this guy, but if you want to use your own thing, then be aware of that. Now, let's import them into the game. So we drag him in, and here he is. And what we want to do is we want to unpack it, prefab. Right click, prefab, unpack, there we go. Give it a new name, let's call it a groover, because it's going to be grooving. Let's rotate it so it's facing our camera. Move it forward. And let's edit it. So all I did was, and I'll redo this bit so you can see, I create a animator, and let's call it groover controller. And then I open the groover, and on your mesh, usually, you have your animation info. It might be elsewhere, but it's here in this case, and it's this one for me. So I put it in, then I go to my scene, and I can actually test it quickly. I'll show you. If I go to the animations tab, I can change this to mixamo.com, and then I press play, and you can see he's doing the thing. He's grooving. And the other one, I'm not really sure why it did this one, but yeah. So, you know, I can't exactly say why that one's there, but, you know, I don't really care enough to do anything about it. So we have our groover, and on entry, it will start grooving. There is an issue. If you click on our animation, change to mixamo.com, and make sure that loop time is set to true, because if it's not looping, then it will not loop. That's pretty obvious. Next, we're going to quickly make a prefab of our object because we might just shatter it in this next step. So we're going to drag and drop it in, and now we're going to do this next bit. Ragdolls. Everyone loves a good ragdoll. Like, don't tell me you've never ever thought about making a ragdoll before. You're lying. Like you don't know what it is, or you don't like them. You're just lying. Okay, I don't want to hear these lies from you. What you need to do is we need to go to game object for some reason, and then 3D, and then ragdoll. And God knows why it's there, but that's where it is. And then we get this wizard. So what you want to do is our hips are a pelvis. Then you press down. The left leg goes into left hips. Then down again. The left leg goes into left knee. Down again. Left foot into foot. Right leg, hips, down, leg, knee, down, foot. And this is important for animators and programmers alike, because you should know how your mesh should work if you want to have this functionality. If you are missing bones, it just won't work. Okay? So please, for the love of God, animators, know what you're doing. Programmers, know what you're doing. Okay? So next we can move down here. Oh, where's our arms? Our left shoulder. Here we go. So we have our left shoulder and our left arm. For the left arm, we're going to do this one. And the forearm is going to be this one. And the right shoulder, right arm, right forearm. And then the middle spine is your neck. And then your head is your head. And then we can create. Cool. So what this is going to do is it's automatically going to add a capsule collider, rigid body, and character joint onto a bunch of the components. And then when you press on your joints, you can now see you have all of these objects. And it does this all automatically. Now, not everything is going to be scaled properly. You can see that his head is, well, clearly there's nothing in there, and that's the issue. So you can make the radius bigger, and you can move it around, because we want to try to get accurate hitboxes here. And there we go. And this is going to be super important for literally everything that we're about to do. Now, let's press back on Groover, who doesn't have an animator for some reason. I don't know why I forgot that part. You can... I guess let's just try the Ragdoll, because at this point the Ragdoll should actually be working. Yeah. So there we go. It Ragdolls. And now when you want it to be alive and not dead, what we do is we just turn on is kinematic on the root. So on the hips is kinematic. And you'll see that now everything else goes limp, which is really just quite tragic now, isn't it? There is a way to make it so that way the rest of them are children. And I believe to do that, we need to change... No, I think we just have to mark them all as kinematic. And then we turn them all on or we turn them all off. So what we'll do is we'll go into prefab view. Well, first we should apply to prefab. So I'm gonna make another prefab of it. Or let's delete the old one. And I'm just gonna drag and drop it back in. Let's go into prefab view. And then I'm gonna do T rigid body to select all the rigid bodies. And then we can make them all kinematic. Okay. We can keep all of this as is. Their masses are automatically applied. Yeah, that should be good. Back out. Okay, there's no other control, I don't think, that we could do. Okay, so now on our hips, well, now everything is kinematic, so we should not fall over. It does not. And now on our main, we can attach an animator and apply our animation with a controller and add it to our prefab. And now it should dance. There we go. So he's grooving, he's doing his thing. And all we need to do, and remember this, all we need to do to get it to do its thing is we need to disable interpolate on everything, I believe. There might be a way to make it so it's only on one, but it looks like it needs to be on them all. That's it, and then it'll ragdoll. Okay? So yeah, he's grooving. Now, there is another thing to this. Let's say you want to add headshots to your game, which is another very common mechanic in shooters. So what we would do is, on all of these objects, we have our own hitbox, which means that they are going to receive hit information. Now, your rigid bodies, each rigid body is going to communicate with one another to the root. So what I mean by that is if we added to this script here, we added a script and we called it enemy controller. Okay, let's edit it. It's going to take its time, because of course it will. And that's a totally different project. Where was that? Okay, whatever. So enter enemy controller. Let's just add in on collision enter. Okay, and then let's print, and then other dot, and then let's do other dot name, transform dot name, and then let's also say print our other dot, and then is there a way to get the articulated quality of the collider you kit? I believe it's this. Okay. Now, we currently have our projectile system from the last time, and there's no reason why they wouldn't hit if we gave our objects colliders, which they do. So we should be able to now hit him, and whenever we do, it should say what part we hit. which it didn't there. Just quickly blast through it, and we got an error. It says other articulation body name. 1 second. Okay, well, I'm actually just dead wrong about this. That's embarrassing. So on our hips object, let's remove this component. And instead, let's apply it to our main here, our enemy controller. So it's now on the root. Then let's go now into our project file and let's create a new script called projectile. Okay. And then attach the projectile script to each bullet. And I don't know how I had that lapse of judgment there, but that was actually a pretty silly blunder on my part. So we'll attach our projectile part to both our bullets. And yeah, so the mistake that I made is I was saying that the enemy collides with the bullets, when usually it's the other way around. The bullet collides with the enemy, right? So delete the stuff at enemy, we'll come back here soon, and in our projectile, we're going to say on collision, enter. And then when you print other transform name, and then let's also print other transform root name, look at the information that we receive. Let's do this in one line, so that way it's easy to read. And let's try now. Okay, and you can see it hits him, and when it hits him, we get all the parts that were hit. So if I shoot again, you can see it's hitting the legs. There we go, it hit his head, his neck, and notice how the root is always Groover. So we can determine what part of him we've hit, and also that it is him in the first place. And that's kind of the important part here, and that is kind of the idea of what we're trying to do. You might have also noticed that a full charge shot will go straight through him. So the first thing that I want to do is correct this fully charged shot issue. Sometimes it'll go through him and sometimes it won't, and it's a really easy fix. The reason for this is because if you have a fast moving object, then the game is going to calculate where it is, and it's going to predict where it's going to be in order to determine if it's going to hit stuff. Now, by default, that's actually disabled, and we can turn it on by just saying that our projectile will extrapolate. We don't need to do it to the other one because it's going to be moving too slow, only the red one because it's going to go really fast. You can also change the collision detection from discrete to continuous if you feel like it's going to be always moving and always fast, but you want to avoid this stuff as much as you can. So now I'm extrapolating, and nope, still. So let's change it to continuous. And it is still clipping entirely through it. Continuous dynamic. There we go. And now it is no longer going through him, and that is exactly what we'd expect to happen. And unfortunately, no one's really going to tell you that rigid bodies do this, unless you're trying to figure it out yourself. Now you know, you do not need to get off of a rigid body just because the collision isn't working correctly. There is a way to work around it. But again, be careful of what you do here, because it might end up causing you performance. Okay, next. Let's go to our projectile, and when our projectile collides, last, we're going to destroy ourselves. Okay? Because that's it. We should just be dead. And the next thing we need to talk about is a coding concept, such as interfaces. Interfaces allow us to apply rules to objects, and it doesn't matter what the object is, we can still apply the rules to it. So I will show you what I mean by that. We're going to create a script, and we're going to call it iDamageable. And this is a very common thing in Unity. If you search up iDamageable, you will literally see this. Then we're going to create an empty, or not an empty, but let's do a cube, and it's literally just going to be a box. Okay? And it's just a box. Like, that's it. It doesn't matter. Yeah. On the box, we're going to add a script to it, and we're going to call it box script. It does not matter. This could be a crate, it could be a door, whatever you want it to be, it does not matter. The important thing is that you need to assign data to it, and there's many ways to do that, but this is the easiest. We just now said that it's a box script. Okay, now let's open our box script. We have our enemy controller script, and then let's also open our iDamageable script. What we're going to do first is our iDamageable script. We're going to remove update and start. We're going to remove the inheritance, and instead of a class, it's going to be an interface. An interface cannot contain any data. You're not allowed to say int and then your name, for example. You can't store any variables. There is a bit of a rule break to this, and it's kind of like a bit of C# cheese that you can do. But the main thing here is that interfaces are weightless classes. They are a set of rules you are defining onto other objects, and what's really awesome about them is you can access these rules and ask them to perform those actions. So, first of all, let's add a bit of cheese. We're going to say public float health, and then get private, no, not get private set, just get set. And this is cheese. The reality is that this is technically a function, not a variable, but the way you access it is like a function. These are called auto properties, and they will automatically generate on the C++ side when it's interpreted to functions, a getter and a setter. Next, we need to create two functions, public void take damage, and a public void, and then it's going to be a die. Now, when you're in this function, or not in this function, but when you're in an interface, you have two options. You can either define a primitive function for it to do, which is mostly strange, or you can say that it's an abstract function, and there is no definition, it must be defined by its child, which usually makes more sense. Okay? Continuing. When you go now to your enemy, and this is done, by the way, I'm going to close iDamageable. When we go to enemy, we can now say it is a monobehavior and iDamageable. You can only do that with interfaces, and that's why interfaces are special. And we're going to do the same for box script. It's a monobehavior and it's damageable. Delete, start, and update. And then we'll get this error because we need to implement our missing members. And there we go. And implement our missing members. Cool. And I believe that there's even something a little cheeky we can do here. And I just want to try this because I'm not actually entirely certain. If we say field, serialized field, like this, I'm not entirely sure if that's going to work. To be honest, I haven't tried that before, but I feel like it might. So let's check our enemy now and see if that is implemented. Okay, no errors. Our cube has the box script, and our groover has health. And you know what? That's awesome, because we don't have to add any more work, and we've forced them all to have health, and we can copy and paste this into our, and I closed it, into our box script. That's awesome. I did not know that. You learn something every day. Okay, so all we're going to do is when you take damage, it's going to be very straightforward. If our health is smaller than 0, then we die. And actually, that kind of begs another question. And we need to modify this, and I totally made another oopsie. So let me go back to iDamageable. Can we make this alone serialized field? No, I figured you couldn't. That doesn't make sense. But could we make this have a default implementation and then modify this here? So float health like this. And then we're going to say that, or not health, but damage. We're going to say that our health subtracted from our damage. And then if our health has decreased below 0, then we should die. Okay, and now if we go to our box script, can we delete this? Oh, we sure can. Oh, I did not know you could do that. That is absolutely lovely. I'm going to put that in all my games now. That's so good. So, okay, and I'll show you why this is so good in a moment. And And now all we have to do is describe how they die. So when a box dies, it's just going to explode. We're going to say destroy, and then game object. That's it. We don't really care. And then for the enemy, when they die, this is where we have a bit more complication. We want it to ragdoll. So we're going to create a private rigid body, and then, well, that's not true. We can cache every rigid body, but I think the reality is we only need to do it once. So, yeah, here's what we're going to do. In die, because die should only ever happen once. If die is happening more than once, then there's an error. Let's add a check just to make sure this never happens. Bool is dead. Okay? If is not dead, then is dead. Or I guess if is dead, return. Else is dead is true. And now we can do our logic here. So we'll only be able to die once, just because we don't want to have to do this more times. Now, what we want to do is we want to get all of our rigid bodies. So I'm going to say get components in children. Here we go. And it returns a T array. So type of rigid body. If you remember from what we just did, we need rigid bodies. Okay, and we need to store it. So we need a rigid body array, and it's going to be called RBs. And then we're going to say for each RB rigid body RB in RBs, RB.isKinematic is false. That's it. Okay, and then let's turn off our animator. So we're going to say RB dot, and then not RBs. We're going to say get component type of animator, and then set active dot it's active. Wait, hold on. Animator is our component. Can we not set this as active enabled? False. Interesting. Oh, because it's not a game object. I'm sorry. I like how my brain is only partially functional, so much so that I learned something from the iDamageable thing, yet my brain stops working when I'm doing a simple task. Oh god, we love it. So this will turn it off, and the assumption here is that we start off animating, so this is true by default, and this is true by default. That's the assumption. You can modify this, of course, as you see fit, but this works in my instance. Let's go to projectile now. And all we need to do is incredibly, incredibly simple. We need to say, first of all, if we can hit our enemies. And here's the awesome part. We can say if other dot transform dot root. And then dot try get component out I damageable. And then damageable. Or you could just call it like hit target. And then check this out. Hit target. Take damage. What? Isn't that awesome? That's it. That's all you gotta do. Now we want to be able to modify this so that way we actually get a whole bunch of flexibility. So we're gonna say over here, public, and then it's going to be a void init function because we want our bullets to be initialized by our gun, and we're gonna have a float charge percent. Okay, and we're going to have a float damage here, serialized, private float damage. Okay, and then let's do another serialized field. It's going to be a private float shoot force. And then we're going to have this object control the shoot force entirely. So let's make a rigid body. It's going to be called... Actually, we don't really need to keep a reference for our collider in this instance. We'll do it anyways, whatever, fine. And then RB equals get component, type of rigid body. And then we could say our RB add force. And we're going to add force in our direction. So let's go to projectile weapon and just see what we could take over. We spawn from our position, and we need to pass down our direction. Let's just pass it down. Vector 3. Fire direction. So that way it's just easier to remain our data, keep it true. And then let's say that our shoot force multiplied by our charge percent, multiplied by our fire direction, impulse, instant force. Great, and then over here, we're going to say our damage. Let's create a float true damage, like this. And this will make more sense next week. We're going to say true damage is equal to, and then it's going to be our charge percent multiplied by our damage. And then finally, on the output, when we do damage, we will have them take damage, and that's literally it. Boxes, enemies, anything that is damageable will now be able to take damage. They will respond accordingly based on their rules, and it's actually just like a beautiful, glorious little system that we've created. Very, very cool. We can also modify this one last little bit, I think. I just want to try it. We can make this a protected set. If we do that and we modify these, non-public access or health set cannot be implemented from interface. Yeah, that's what I thought. Okay, never mind. We cannot do that. That's fine. The only downside to this is health is now a public variable, which means that your projectile could literally say hit target.health equals 0. That's the major downside to this, but the upside to this is you're kind of forcing this to work. I'll be honest, there's a better way you could do this. It's less lazy. That would probably just work. I'm not going to bother going through it, but you wouldn't do auto properties instead. So that way your set function doesn't need to be private. The advantage of this is it's super lazy, like super lazy. Anyways. So on our cube object, we have our health. Let's go to health at 10. On our groover, we're going to give it a health of 100. Apply it to prefab. Okay, and then on our prefabs, bullet 2, we need to apply its stats. So shoot force is 50, and damage is going to be, I don't know, let's just say 20. So at full force, it's 20. And then the other one is going to be the same thing. So 20 and 50. Okay, and Unity is auto-saving my stuff for some reason, but alright. And now when I shoot stuff, they should take damage. Our box is not being destroyed. Don't tell me it's not working. I'm actually gonna cry. Let's check quickly. I would have been so happy. Print has taken damage. We're gonna print our other transform. We've already done that. We don't need to do it again. If just print has taken damage. Okay, and then what we'll do in our interface, we're going to print our health. Debug.log. Whoa. Okay, well, let's try this. It's not setting it. You see that? It's only... I kind of suspected that that's what would happen. Because we are decreasing it, but it's not actually being affected. Cringe. Okay, I'm going to play around with it and I'll come back to you and I want to see if there is a way to make this work, but I'll be right back. Well guys, I think it's evident that I need to get more sleep. I never called the init function, so true damage was 0, and therefore it was taking 0 damage. Clearly, I have a skill issue that needs to be assessed. So, let me just go and fix this mess that I made here. And maybe that does still work, it's just me being silly. Go back to the projectile weapon script, and we need to, instead of making rigid bodies, we're going to make projectiles. Okay? And then we'll do this. And then instead of this, we're going to say projectile, and then, or not projectile, but it was rb.init. And we're going to init our charge percent by the fire direction, which is our camera ray direction. Okay. Other than that, it is exactly the same. We can now remove force, and then we have our projectile, which is now saying it is responding. Yay, I'm blind. Let's fix this quickly. Okay. And then this get component thing, it says it's not happy with, so what we can just do is this. Honestly, it does not matter. Like this is fine. Okay. At least I'm pretty sure that is fine. Whatever. So let's test it now, or maybe that, or I just like blundered terribly. Let's give this 10 health. We'll find out in a second. And I forgot to assign the objects. Of course I did. Weapon, bullet 1, and bullet 2. This is also going to force you to have the right things attached to your objects to be able to shoot them in the first place. And, okay. No, I did make a blunder. This does need to go in here. And then, if you're on writer, you just turn this off because it's wrong. This only happens once, this function, so it's not a worry. Either that, or you can pre-cache it on the object, which isn't a terrible idea either, to be honest. Maybe let's do it that way. So let's not store it like this. Let's make it serialized. And change the name. Move it up. And now let's just apply it. So that way we don't have to like, I mean it's a little bit more like CPU time to load it, I believe, is the disadvantage to this. But in the future, I believe this actually just makes more sense. In the future. And there we go. Okay, it does work. 2, 3, 4, and he's dead. And he ragdolls. Lovely stuff. So now the next thing is this clipping through the ground or is it being destroyed by the ground? It's clipping through, right? Oh, it's being destroyed. It's colliding with the plane. Actually, no, I guess we did say that. Okay. Well, that's fine. So he dies now. Let's say we want to add headshot damage, which again is a pretty common thing in games. So what you can do is one of two things. You can either do layers or you can do tags. For the sake of I believe this is actually a system you do with tags, but layers are significantly more optimized because of how numbers work. So a layer would be 5 times faster than a tag on average. But I believe in this instance you can actually get away with doing tags, and it's completely fair to do so. So let's do that. On the head object, I'm going to assign a tag that's just called head. Or you could also just do layers, but I think that tags make the most sense here. I'm going to make another one that's called limb, and another that's called body. And then I'm just going to run through and apply them. So this is a body part. And apply to prefab. This is the left leg, foot, all 3 of these. They are going to be our limb. Okay, and we will apply to prefab later. And these guys are all going to be limbs. And then our spine. Something else. Shoulder here and your shoulder here. These are also going to be limbs. And then your neck and your head are both going to be head. Let's quickly press on our guy and make sure that it's set up correctly. And then our hips should be this big one in the middle here. I think that's good to go. So here's what we're going to do. And this is like Siege-inspired damage numbers, because that's like, I don't know. When I think of damage numbers from hit regions, is what I think of. So I'm going to delete this. It was just a print line that I had. Let's go to our projectile script, and let's delete these print lines. Or let's not, because we might still want it. What we want to do is we want to modify our damage based on the object type that we hit. So let's make a switch statement. and we need to switch our other transform root tag. Now, if we're accessing a component more than once, we need to store it, so that way life isn't pain and suffering. So transform root equals, and we'll store it like this. And I'm actually dead wrong. I'm just thinking about it. It's not that. It's other dot and then compare tag. Other dot transform dot compare tag. And we don't want the root, because the root is always going to be like the enemy itself. This transform is the thing that we actually hit. And then if you're in writer, it'll tell you all your options. So we really just want to say dot tag. And then we want to set up our cases. I'm not sure if this is the best way to do tags, to be honest. But if you do it this way, it's going to be constant at least. Okay, we can say X, Y, Z, and then defaults. And we actually can ignore this last one. And then body shots is going to be default. So over here, we can say true damage, and then, yeah, we don't need a default even. If we hit a limb, so what do we call our limbs? It is just a limb. So if we hit a limb, L-I-M-B, then true damage is multiplied by 0.8 F. And if we hit the head, then true damage is multiplied by 2. And then finally, let's output our damage. Okay. And there you go. So now we should be able to tell what limb we are hitting, and we're calculating headshots in the process. Apparently there's an error somewhere. Okay, writer. See, I'm not sure if writer's tired or I'm tired, but it's hard to tell. So now when I shoot it, and that works just the same because it's default, and when I hit him in the head, let's see if I can actually pull it off. There you go, has taken damage. Did we hit his head? We hit his neck, and it did not do that much damage. Has taken damage. Okay, let's hit him in the head again. Where is it? Has taken damage. We hit him in the head, but it only did 20. Okay, so it didn't quite work. So let's printly quick the tag. Thank you, brain. Amazing. And let's just see what we're getting from this. Okay, and it does say head, as a matter of fact, and I am very, very slow, apparently. That's just amazing, isn't it? God damn it. Well, I apologize for the length of this one, but hopefully you can see all the concepts, and I'm actually just going to pull this up really quick and just see if I missed anything, because there's quite a bit that I wanted to go through. Yeah, there you go. So we hit him in the head, it does 40, and we hit him in a leg. It should do less, although it's going to be a lot harder to hit him in a limb. Let's see, we hit him in the right forearm, and it did 20 damage. The right forearm. Right forearm. And it is untagged. That is actually a mistake. The right forearm should be... Oh, can you not control click to tag multiple? You can. Did I just miss that? Strange. Okay, and we need to reapply to prefabs, so I'm going to go to the prefabs. I'm going to go to Groover, rather, because that's where he's kept. He's a Groover, and we put him back, prefab him again. Okay, never mind. Let's unpack him first, and then let's prefab him. And now let's put a few of them in. Put the box somewhere off to the side. We don't care anymore. They're not cool. This is important. I don't care what you say. I need this, alright? Okay, and let's test it now. So we hit him. And hit him in the limb for 16 points. And that was a full charged attack. And then I hit him in the head. and we hit him for 40. There you go, headshot and limb shot damage. And that was all really simple, and all the parts meshed together. Now I'm going to quickly look and see if there's anything else. Yes, there was one thing that I forgot to mention, and I'm kind of embarrassed that I forgot to mention it. Physics materials. And this is actually straight up something that nobody teaches you for some reason, but it makes no sense, because this is like an essential part of Unity, and if you don't know about this, then life is pain and suffering. If you add a rigid body to something, and you add force to it, for example, your player, you might notice that it will always accelerate, and that is painful. Now, if you watch a YouTube video, they might tell you to go and add some drag to it. And you're like, oh, that works. So here's what we're going to do on the box script. What we're going to do is we're going to say, we need to go forward. So all we're going to do is make the update function, and every frame we're going to say, we're going to add force. So serialized field, well, that's not serialized field, that's cringe. Private, rigid body RB, and then let's make awake. RB is our get components type of rigid body. So we have our rigid body access, modify this, and then an update, add force, and we want to add force in the forward direction. So just say vector3 dot forward, doesn't matter, just that, and then let's add another variable for speed just in case. Private float speed. Now, you're gonna hear silly things like, oh, turn on drag. We love drag. Always be raycasting. That's what I say. God. I've seen so many bad tutorials. Like, after you learn this one trick, you're like, why? Why were the other tutorials like this? So now I move, and let's turn off our collision restraints, so we're freeze rotations. Okay, and now let me turn the drag back down. So by default, when you add force to it, you'll see that if we did a speed of 1, maybe not a speed of 1, if we did a speed of 5, it would just slowly get faster and faster and faster and faster. So what you'll normally hear is, okay, then you clearly need to add drag. And then you're like, look, that looks much more normal. But the reality is, if we turn down the drag, the reality is the same shenanigans are still happening. Right? And here's what's even worse. If you have to have a high drag for whatever reason, and then you put it into the sky, that is not how physics works. Right? So if you make a character that's jumping and it's like, oh, you need to do drag, congratulations, the tutorial you're watching it from, they probably don't know what's up. And that really sucks, because it's like, it's such a simple system to fix this. It's just, for whatever reason, you don't find this on the internet. Okay? So drag down to 0, because you don't fall slower, no. Okay? And then you can keep your speed as is. And then what we're going to do on the ground, we have a physics material option. So go to project, create a folder for physics materials, open the folder, create a physics material, and let's call it ground. And then you just change it. Let's make it bouncy. Why not? So now the ground will permanently bounce my objects. And then I'll show you like more of an actual example of how we can use this. But look, now it's bouncy. Okay? Let's also modify this, so that way it is our friction. So instead of bounciness, let's put it down to 0. And I'll see that when it hits the ground, there is a limit to its acceleration. So we need to turn up the friction. The dynamic friction is the moving friction, and the static friction is the force needed to actually be able to move. Okay, I have made it too much. I believe you can't test it. Oh, no, you can. So you can play with it in the inspector, because it is a scriptable object. Okay, it's probably easier to do this with a player that you can actually physically control. we can increase the static and decrease. Okay. It is actually still accelerating. So that might have just been an oversight on my behalf. I suppose if you're adding force every frame, that's just what's going to happen. If we change it to multiply, and it's just a matter of playing with it, but it kind of sucks to play with it in the first place. So I'm going to play with it quickly, and I'll come back in a moment. Alright, fine, I was wrong about the speed thing. But it's a better solution to drag than drag is to drag, okay? Don't use drag, use physics material. And because especially it allows you to do stuff like trampolines and other fun physics stuff. Now, because I feel like I have said it would do max speed, and now I have just lied to you, I'm going to add it quickly. To do a max speed, what you'll do is you'll take your adding force, and we will just get our speed from this, and we'll clamp it. So RB, velocity, and then magnitude is our speed, or current speed. Okay, and then what we can do, and there's a lot of options here. We could. What's the best way to do this? I'm not sure. Sometimes you just ask ChatGPT and call it a day, but here's what we're gonna do. We're gonna say that current speed, and then vector 3, and it's going to be normalized, is going to be equal to the RB velocity divided by the current speed. So we have a normalized vector, and then we can pre-store this as a vector 3 velocity. Okay, and then what we're going to do is we're going to say if the current speed is greater than whatever number is greater than our max speed, if the current speed is greater than max speed, which is 5, doesn't matter, then we normalize our vector and we can set the velocity RB dot velocity is equal to the normalized vector multiplied by your max speed, which is 5. I'm pretty sure that'll work. That'll force the speed to only ever be 5 at most. Normalizing a vector isn't cheap. There might be a better way you can do it. But there you go. So now you can only ever move at most 5. You can limit speed like that if you want. A lot of games do tend to have a speed limit. But there you go. I did my job, okay? Sorry the video is so long. And I'll see you guys next time.